2 trillion galaxies. Sit with that number for a moment. Not 2 trillion stars, 2 trillion galaxies, and each one holding somewhere between 100 million and 100 trillion stars of its own. Do the arithmetic and you land on a number of stars so large that our language simply gives up. There is no everyday word for it. You can write it down, a 2 followed by more zeros than you would care to count, but you cannot picture it. Nobody can. And around most of those stars, planets. We know this now. We have measured it. The sky is not empty scenery. It is packed, absolutely stuffed with worlds. And here you are on one of them, apparently the only one where anybody is home. That is the thing that should stop you cold. Not that the universe is big. Everybody knows the universe is big. The thing that should stop you is the silence. All that room, all those chances, all that time. And so far, from every direction we point an instrument, nothing looks back. No signal, no structure that shouldn't be there, no visitor knocking, no stray radio whisper that carries the fingerprint of a mind. Just the hiss of hot gas and cold rock and the slow burn of distant suns going about their business. How can both of those things be true at once? A universe overflowing with places for life, and a sky that stays perfectly, stubbornly quiet. That is the whole puzzle. And I have to tell you, the honest answers to it are far stranger than the science fiction version most of us grew up on. Stranger and better. Most of us were handed a story where the galaxy hums with starships, where distance is a minor inconvenience, where somebody is always just over the next ridge of stars waiting to say hello. That story is comforting. It is also, I think, almost certainly wrong, and wrong in ways that are more beautiful than the story itself. So sit with that question. Really sit with it. We are going to earn the answer slowly, one careful step at a time, and by the end you will look up at the night sky and see something you have never quite seen before. Before we reach for any answer, we have to be honest about a harder question. How do we know anything at all about a place we can never visit? Because that is the situation. You cannot go to another galaxy. You cannot go to another star. You, personally, will never stand on an exoplanet, which is simply the name for a planet orbiting some star other than our own. Nobody will, not in your lifetime, probably not for many lifetimes after. So everything we are about to reason through, we reason through from our armchair, from light, from arithmetic, from the small handful of things we can actually measure. And I want you to trust the chain. So let me show you how the chain is built, link by link. Because a conclusion is only ever as strong as the weakest step you took to reach it. Start with the most important fact in all of astronomy, and it is a fact about time, not space. When you look up at a star, you are not seeing it now, you are seeing light that left it years ago. A light year is simply the distance light travels in a year, and light is the fastest thing there is. Nothing beats it. So the light from a star 10 light years away left a decade ago. The light from a galaxy 10 million light years away left when creatures we would barely recognize walked the Earth. To look out into space is to look backward in time. Always. There is no way around it. Let me make that concrete, because it is easy to nod at and hard to feel. The sun you see is 8 minutes old. If the sun blinked out this instant, you would carry on in warm daylight for 8 full minutes before the sky went dark, because the last light it sent is still on its way to you. The nearest bright star to the naked eye is years old by the time it reaches your retina. And some of the faint smudges you can pick out on a clear dark night are whole galaxies. Their light 2.5 million years in transit, having set off before your species had a name. Now push that further, because the further you push it, the stranger and more wonderful it gets. There are galaxies whose light has been traveling for over 13 billion years to reach the telescope that caught it. When that light set out, there was no Earth, no sun, no solar system at all. The atoms that would one day become your body were scattered somewhere else entirely, not yet gathered, not yet you. And that ancient light has been crossing empty space the whole time, patiently, at the only speed it knows, arriving at last on a lens we built only in the past few years, You are catching photons older than the ground under your feet. That single fact is the foundation of everything. It means the sky is not a photograph. It is a history book with the oldest pages farthest away. Now, here is why that matters for our question. The universe has an age around 14 billion years. And because looking far means looking back, there is a distance beyond which we simply cannot see because the light from anything farther has not had time to reach us yet. That edge has a name, and the name is beautiful, the cosmic microwave background. It is the oldest light in existence, the faint afterglow of the young universe, and it forms a wall, not a wall of matter, a wall of time. We cannot see past it, not because our telescopes are too weak, but because there is no older light to catch. Think about that. Our knowledge has a boundary, and the boundary is not our ignorance. It is the age of everything. And here's a subtle twist worth pausing on. That oldest light was born hot and bright, the glow of a universe once as scorching as the surface of a star. But the universe has been expanding ever since, stretching the very space that light travels through. Stretch a wave of light, and it grows longer, cooler, redder. Stretch it enough over 14 billion years, and that once blazing glow arrives as a faint whisper of microwaves, barely above the cold of empty space. That stretching has a name too, redshift. The light waves get pulled longer and shift toward the red as they cross a growing cosmos. And redshift is not just a curiosity. It is the ruler we use to measure how far and how far back we are looking. Let me show you why that ruler is trustworthy. Because a ruler you cannot check is no ruler at all. Every kind of atom, when it glows, gives off light at very particular colors. Fixed colors, a fingerprint. Hydrogen glows in one exact pattern, oxygen in another, and those patterns never change, here or anywhere. So when we catch the light of a distant galaxy and find that whole fingerprint shifted toward the red, stretched by a known amount, we are not guessing. We are reading the same atoms we know from a laboratory, only stretched by the expansion of space in between. The further away, the more stretched. That relationship holds so reliably that we turn the amount of redshift straight into a distance and straight into a look-back time. The ruler checks out against itself over and over. That is why we can say 13 billion years and mean it. So already we have learned the first rule of this whole enterprise. Every answer we get comes wrapped in a limit, and the honest thinker names the limit out loud. How, then, do we know there are planets out there at all if we cannot go and check? We reason from starlight, and the trick is gorgeous. When a planet passes in front of its star, from our point of view, it blocks a tiny sliver of the light. The star dims just a hair, then brightens again. Do that over and over on a regular schedule, and you have found a world. You never see the planet. You see the shadow it casts on its own sun. From the depth of that dimming, you get the planet's size, because a bigger planet blocks more light. From the timing, the steady rhythm of the dips, you get its orbit. From the orbit, you get its distance from the star, and from that, its temperature. All of it from a flicker. And I want you to feel just how faint that flicker is, because it is the difference between a clever idea and a working measurement. A planet the size of the Earth, crossing a star like our sun, dims that star by roughly 1 part in 10,000, 1/100th of 1%. Imagine standing far across a stadium at night, watching a single bright floodlight, and trying to notice the instant a moth crawls across the face of it. That is the scale of the signal we are catching from trillions of miles away again and again on schedule. And the schedule is the proof. A single dip could be anything: a cloud of dust, a flaw in the instrument, a flicker of the star itself, but a dip that returns every 90 days precisely for years is a planet on a 90-day orbit. The regularity is the fingerprint. Nature rarely repeats itself that patiently by accident. And there is a second trick worth knowing, because two independent methods pointing the same way is exactly how trust is built. A planet does not just orbit its star, it tugs on it. The star wobbles ever so slightly, pulled by the gravity of the world circling it. And that wobble shows up in the star's light, shifting it a touch bluer as the star swings toward us and a touch redder as it swings away. Measure the wobble and you get the planet's mass. Now put the two methods together. The dimming gives you size, the wobble gives you mass. Size and mass together give you density, and density tells you whether you are looking at a ball of gas or a world of rock. From nothing but patient attention to starlight, we can tell a gas giant from a place that might have solid ground under your feet. And there is a third thing this starlight gives us, and it is the most extraordinary of all. When a planet crosses in front of its star, a sliver of the starlight does not just get blocked. Some of it passes straight through the planet's atmosphere on its way to us, if the planet has one. And that thin skin of air leaves its own fingerprint on the light, absorbing certain exact colors as it passes through. Read those missing colors and you are reading the air of another world. Water vapor, carbon dioxide, methane. We are, right now, beginning to taste the atmospheres of planets we will never visit, from the faint stain they leave on their own star's light as it filters past. Sit with how audacious that is. We are chemists of worlds we cannot reach. We have found thousands of exoplanets this way, thousands of confirmed worlds, and that is only the small patch of sky we have stared at closely, with only the instruments we happen to have built so far. Run the numbers outward, and the conclusion is unavoidable. Planets are not rare. Planets are the rule. Most stars have them, and a healthy fraction of those planets sit in what we call the Goldilocks zone, the band of orbit around a star that is not too hot and not too cold, where a world could hold liquid water on its surface, not scalded away, not frozen solid, just right. And worlds in that comfortable band appear to be common too. And this is where scientific literacy earns its keep, because I need you to notice the shape of what we just did. We did not assert that planets exist because it would be nice. We built the claim out of measurable dimming, out of a measurable wobble, out of arithmetic anyone can follow. That is the difference between a thing we know and a thing we hope. A real claim carries its own mechanism inside it. You should always be able to ask, and how exactly do you know that? And get an answer that does not end in someone's authority, but in something you could, in principle, go and check. Which brings us to the single most important idea in this entire video. A claim is only worth anything if you can imagine what would prove it wrong. That word is falsifiable. If nothing could ever contradict an idea, then the idea tells you nothing about the world. The dimming of a star is falsifiable. If the star did not dim on schedule, there would be no planet on that orbit. The wobble is falsifiable. If the star sat perfectly still, there would be nothing tugging on it. Beautiful ideas that can never be tested are just stories, and we are not here for stories. We are here for the working. Keep that test in your pocket for the rest of this. Every time we reach a claim, quietly ask yourself, what would the universe have to do to prove this wrong? If the answer is nothing, be suspicious. One more tool, and then we are armed. It is called the Copernican principle, and it is really just an assumption about humility. Copernicus moved the Earth out of the center of things. For most of history, people assumed our world sat at the middle of creation, with everything else wheeling around us. He showed that the Earth is just another planet going around the sun like the rest. The principle named after him says, keep going. Do not assume you are special. Do not assume your position, your moment, your circumstances are the privileged one in the cosmos. Assume you are typical unless you have a reason not to. This is sometimes called the mediocrity assumption, and it sounds like an insult, but it is a discipline. It stops us flattering ourselves, and flattering ourselves is the single most reliable way to get the universe wrong. And notice how often that discipline has paid off. Every single time we assumed we were at the center, we were wrong. Earth was not the center of the solar system. The sun turned out to be an ordinary star, not the middle of anything. Our galaxy turned out to be one of billions, not the whole of creation. Every step of that story pushed us further from the middle, and every step turned out to be true. So when we ask whether we are the one special place where life woke up, the Copernican principle whispers a warning. History has not been kind to the idea that we are the exception. Keep that in mind. We will need it. So there is our toolkit. Light as a time machine, a wall of oldest light we cannot see past, planets counted by their shadows and their tugs, and even tasted by the light that filters through their air. The demand that every claim be killable, and the refusal to assume we are the center of anything. Hold all five. Because now we can finally ask the question properly. Here is a thought experiment, and I want you to build it with me piece by piece. Imagine you are handed a bag of dice. Not six-sided dice, enormous dice, each one with 100 billion faces, because that is roughly how many stars sit in a typical galaxy. Now imagine you have not one bag, but 2 trillion bags, one for every galaxy we can see. And your task is simple. You throw all of them, every die, every bag, and you ask, on how many faces does life come up? Nobody knows the odds on a single face. That is the honest truth. But watch what happens to the arithmetic when the number of throws gets this large. Suppose life is wildly, absurdly unlikely. Suppose it comes up on only one face in a billion. You would still expect life to appear over and over a staggering number of times across all those bags. 100 billion stars in a galaxy, 1 in a billion odds, that is still around 100 living worlds per galaxy, times 2 trillion galaxies. The sheer count of throws seems to overwhelm any reasonable unluckiness. That is the intuition almost everybody starts with, and it feels airtight. With that many worlds, of course we are not alone. It seems obvious. It seems like the numbers do the work for you and no further thought is required. Now, here is the turn. That intuition secretly assumes we know the odds on a single face are not truly tiny, but we do not know that. We have exactly one example of life arising. One, this planet. And you cannot measure a probability from a single instance. If I flip a coin once and it lands heads, I have learned almost nothing about the coin. Maybe it is fair. Maybe it has heads on both sides. Maybe it lands heads once in 1,000 throws and I just happen to catch the one. A single result cannot tell those apart. Life happening here tells us it is possible. It tells us the odds are not zero. It tells us nothing whatsoever about whether the odds are 1 in a billion or 1 in a billion, billion, billion. And once the odds on a single face get small enough, even 2 trillion galaxies is not enough. The vastness stops rescuing you. And here is the sharpest part of that blade. We could not possibly find ourselves on a world where life failed to arise. There is nobody there to look. So the very fact that we exist and can ask the question guarantees we are sitting on a world where the dice came up life, no matter how rare that outcome is. Our own existence cannot be evidence that life is common, because we would be here to notice it, whether life happens on 1 world in 10 or 1 world in a billion trillion. The winner of a lottery cannot conclude the lottery was easy to win just because they won. Somebody had to. And that somebody is always, by definition, standing exactly where you are standing, holding the winning ticket, tempted to think the odds must have been good. Let me make that shift real with a number, because it is easy to wave at and hard to believe. Suppose the true odds of life on a given world are not 1 in a billion, but 1 in a billion trillion trillion. That is a number so small it feels made up, but nothing forbids it. And at those odds, you could throw every die in every one of the 2 trillion bags, every star in every galaxy in the entire observable universe, and still expect life to appear essentially nowhere. Perhaps exactly once. Perhaps here. The universe would be precisely as vast as it is and precisely as empty as it looks, and there would be no contradiction at all. Do you feel the ground shift? The bigness of the universe was supposed to guarantee company, but bigness only guarantees company if the odds are within a certain range, and we have no idea if they are. Our one example is not a data set. It is a single anecdote, and you cannot build a probability out of an anecdote. This is the first crack in the comfortable picture. We assumed the numbers were on our side. We never checked whether the numbers even could be. There is a way. People have tried to organize this exact uncertainty, and it is worth knowing by name, because it is the most famous equation in the search for life. The Drake equation. Do not let the word equation scare you. It is not a formula that spits out an answer. It is a way of being honest about your own guessing. It takes the big question, how many talking civilizations are out there, and breaks it into a chain of smaller questions you multiply together. How many stars form? How many have planets? How many of those planets could hold life? On how many does life actually start? On how many does life become intelligent? How many of those build something we could detect? And how long do they last before they fall silent? Every one of those is a fraction. Multiply the fractions and you get your estimate. And here is the delicious, maddening thing about the Drake equation. The first few fractions we now know reasonably well. Stars form constantly. Planets are common. Worlds in the temperate zone, the Goldilocks band, are common. Those first links in the chain have firmed up enormously in just the last few decades, and every one of them firmed up in the direction of more, not fewer. But the later fractions, the ones about life actually starting and lasting, we do not know, even to within a factor of 1 trillion, we can make the final answer come out to 1 million civilizations, or to less than 1, just by nudging the fractions we cannot measure. Not cheating. Just choosing honest-looking guesses that nobody can yet rule out. Let me show you exactly how loose that is, because it is worth feeling in your hands. Take the fraction for how often life actually starts on a suitable world. Some thoughtful people guess it is nearly 1, that wherever conditions allow, life gets going almost every time. Others guess it is 1 in 1 trillion. A fluke so rare, it might have happened only once in the whole universe. Both guesses come from serious minds. And notice, there is no measurement yet that rules out either one. That single fraction, all by itself, can swing the final answer by more than 20 zeros. Now stack another uncertain fraction on top for how long civilizations last, and another for how often life turns clever. And you can see the whole equation flapping in the wind. The known fractions barely move the total. The unknown ones control everything. And notice how neatly this obeys the test we put in our pocket. The fractions we know because they are falsifiable. Count the stars, count the planets, and you could be proven wrong by the next survey. The fractions we do not know precisely because we have no observation yet that could pin them down or knock them over. The equation quietly sorts the checkable from the uncheckable, and that is its genius. So the equation does not answer the question. That is not its failure. That is its honesty. It shows you exactly where the boundary of your knowledge sits. It sorts what we know from what we are guessing, and then it hands the guessing right back to you. And what is left after all that? 2 enormous unknowns standing side by side. Does life start easily or almost never? And when it starts, does it last or does it snuff itself out fast? Everything, the entire answer to whether the sky should be crowded or quiet, hangs on those 2 fractions. And our one example, this planet, cannot pin down either one. We do not even know how long our own answer to the second question will be, because we are still, at this very moment, living inside it. So the first revelation is not an answer, it is worse and better than an answer. It is the realization that the numbers we thought were on our side were never counted. The universe is enormous. That much is real. But enormous is not the same as guaranteed. And that gap between enormous and guaranteed is exactly where the silence lives. Now leave the odds behind, set them down, because even if life is common, even if 1,000 civilizations are out there right now, there is a second wall between us and them, and this one is not about probability at all. It is about the plain, brutal arithmetic of distance. Let me build you the scale, because you cannot feel it until you build it. The fastest object humans have ever launched moves at a few tens of kilometers per second. That is genuinely fast. Fast enough to cross your country in under a minute. Fast enough that if you blinked, it would have traveled farther than you could throw anything in your life. Now, the nearest star to our sun sits about 4 light years away. 4 years traveling at the speed of light, our fastest probe, moving at its very best, would take not 4 years, not 400, around 70,000 years to cover that distance. 70,000 to reach the very nearest neighbor star. One single step into a galaxy, 100,000 light years wide. Let that land. The nearest star and our best machine needs longer than all of recorded human history many times over just to arrive. If our earliest ancestors had launched such a probe when they first learned to make fire, it would still not be there. It would be barely a fraction of the way. And that is the nearest star, not a promising one, not a chosen destination, just the closest speck of light in the whole sky. Now widen the frame, because the nearest star is only the first inch. Our galaxy is around 100,000 light years across. At the speed of our fastest probe, crossing it end to end would take not 70,000 years, but something closer to 2 billion years. 2 billion. That is a span comparable to the time life has existed on Earth at all. A single trip across our own galaxy at speeds we can actually achieve would swallow nearly the entire history of living things on this planet. And that is one galaxy out of 2 trillion. The scale does not merely humble you. It refuses to fit in your head, no matter how hard you push. And here is where the light speed limit turns the screw. Because the speed of light is not just fast, it is the ceiling. As far as we can tell, nothing carrying information or matter can go faster. It is not a technology problem like breaking the sound barrier was. The sound barrier was a wall of air. We simply had to push hard enough through. This is different. This appears to be a rule woven into space-time itself, the fabric of the universe, the very stage on which distance and time are measured. So 4 light years means at least 4 years for anyone, no matter how advanced, and realistically far longer, because reaching light speed itself demands more energy than you can imagine. The closer you push toward that ceiling, the more energy each additional sliver of speed costs, and the cost climbs without limit. You never quite arrive at the ceiling. You only ever approach it at ruinous expense. Speaking of energy, there is a phrase you should carry with you: escape velocity. It is the speed you must reach to break free of a planet's gravity and not fall back. For Earth, it is about 11 kilometers a second. And getting a single spacecraft to that speed already takes a tower of burning fuel taller than a building, most of which is fuel whose only job is to lift the rest of the fuel. That is just to leave the ground. That is the first inch of a journey measured in light years. Now scale that effort up to crossing between stars, and the energy budget becomes something close to obscene. To push a real ship with real cargo up toward any useful fraction of light speed, and then slow it down again at the other end, would demand more energy than our entire civilization produces in a very long time. Orbital mechanics, the careful arithmetic of how things move under gravity, does not hand you shortcuts here. It hands you a bill, and the bill is enormous. Let me put a real figure to that bill, because vagueness lets you off the hook. To accelerate even a modest ship to 1/10 of light speed, and no more, you would need a quantity of energy comparable to everything our entire species uses in centuries, poured into a single vessel. And that only gets you moving. To stop at the far end, you pay the whole bill again, because slowing down costs just as much as speeding up. There is no coasting to a gentle halt across interstellar space. There is no friction out there to slow you kindly. Whatever energy you spent to get fast, you must spend again to get slow. So double the obscene figure, and remember that at 1/10 of light speed, the nearest star is still a 40-year crossing, one way, for a probe that arrives already spent. So picture a civilization out there, clever, ancient, everything gone right for them. And they look up at their sky, and they face the very same wall you and I face. Their nearest neighbor is years away at light speed, tens of thousands of years away at any speed they can actually reach. To send even a single ship is a project spanning longer than their civilization has existed. To colonize the galaxy star by star is a task measured not in centuries, but in millions of years. And that assumes nothing ever goes wrong across all that time. No war, no forgetting, no loss of will across 10,000 generations who will never see the destination their distant ancestors aimed for. Do you see what this does to the silence? It may not be that nobody is out there. It may simply be that everybody is stuck at the bottom of their own gravity well, staring across distances that arithmetic itself refuses to shrink. The galaxy might be full of life, every one of them just as marooned as we are, every one of them separated from every other by gulfs that no amount of cleverness can cross in a reasonable time. Not because they lack the desire, not because they lack the intelligence, because the universe simply put the tables too far apart, and there is no cleverness that closes a gap the fabric of space-time holds open, and there's something almost nobody sees here. We imagine contact as the natural state, and distance as a mere obstacle to be engineered away. But flip it. Distance is not the obstacle. Distance is the default condition of the universe. Separation is what space-time does. The gaps are not a bug in the cosmos. They are the main feature. Emptiness is not the exception between the stars. Emptiness is what the universe is mostly made of, and the stars are the rare specks. If you shrank the sun to the size of a grain of sand, the nearest other grain would sit miles away, and between them, nothing but dark. That is the true texture of things. Not a crowded room, an almost perfect emptiness, dotted with the rarest possible sparks, and a radio signal faces the very same tyranny. Softened only slightly, a message travels at light speed, the fastest anything can go, and yet a hello sent to a civilization 1,000 light years off, a near neighbor by galactic standards, takes 1,000 years to arrive and 1,000 more for any reply. 2,000 years for a single exchange. Whole civilizations rise and fall on Earth in less time than that. So even a conversation, the cheapest kind of contact, made of nothing but light, is a correspondence stretched across the lifespans of empires. You would send your greeting and be long dead before it was even heard. So even set the odds aside completely. Even hand yourself a galaxy teeming with neighbors. The second revelation stands on its own. The silence might not mean absence. It might mean that everyone is shouting across a room so vast that no shout ever arrives. Distance and time are the same currency out here. And nobody, however brilliant, has enough of it to spend. Now for the strangest turn of all. Because so far we have talked about space and about odds. This third one is about time, and it will genuinely bend your sense of where you stand. We have been assuming, without quite saying it, that if civilizations exist, they exist now at the same moment as us. But think about what now even means across the cosmos, when the light you see is always old. Here is the thought experiment. Imagine the entire 14 billion year history of the universe compressed into a single calendar year. The whole thing, from the first light to this very sentence, squeezed into 12 months. On that calendar, the first stars flicker on in the winter. Galaxies assemble over the spring. Our own sun does not even form until late summer, around the start of September. Life on Earth appears not long after, then spends an almost unbelievable stretch, month after month, as nothing but single cells, tiny and mindless, going nowhere. Complicated life, the kind you could see without a lens, does not show up until deep into December. And every human being who ever lived, every civilization, every war, every song, every telescope, all of recorded history, fits into the final seconds before midnight on the 31st of December, the last breath of the year. Our ability to send a signal into space occupies not even the final second. It occupies the final flicker of the final second. Let me stretch that image even tighter because the numbers are almost unbelievable. On that calendar, 1 second is about 440 years of real time. So the entire span of recorded human history, from the first written word until now, takes up around 13 seconds of the whole year. And radio, our only means of shouting across the stars, is about 1/4 of a second old. 1/4 of a second at the very end of a year-long story, blink, and you have missed the entire window in which our species could be heard at all. Now ask yourself to line up that quarter second against somebody else's quarter second, somewhere on the same calendar, and see how hopeless the coincidence becomes. Now ask the obvious question. If another civilization exists somewhere out there, what are the odds that its final seconds line up with ours? That its brief flicker of technological life overlaps in cosmic time with our brief flicker? The answer is chilling and clarifying at once. Almost none, because a civilization that can send signals might last a few centuries, a few thousand years if it is lucky. Against 14 billion, a few thousand years is nothing. It is a spark, and you are asking two sparks struck at random moments across a year-long calendar to happen to burn in the very same second. They almost never will. A civilization could have risen and fallen 100 million years ago, and its light of intelligence would have gone out long before we had eyes to see it. Another might not stir for another billion years, long after we are dust. The galaxy could be dense with the ruins of the departed and the cradles of the unborn, and we would sit here in our one lonely second and call it empty. Imagine a great hall with 1,000 candles, each lit for one instant at some random point across 100 years, then snuffed. Walk into that hall at a random moment, and the overwhelming odds are that you find it dark, even though 1,000 flames burned there, not because the candles were rare, because the moments almost never overlap. This is the piece almost everyone misses. When we ask, are we alone, we are really asking two questions tangled into one. Are we alone in space? And are we alone in time? And the second question is far more merciless than the first. Space you might cross, given impossible patience, but you cannot travel to another moment. If they lived 1 billion years before you, no ship reaches them. If they live 1 billion years after, no signal waits that long. The gap in time is a wall with no door in it at all. Distance, in principle, has a door, however heavy. Time does not. Time only runs one way, and it does not stop to let anyone catch up. And now bring back that fact from the very beginning, the one about light being old. It sharpens this to a knife's edge. When you look at a distant galaxy, you see it as it was sometimes billions of years ago. So even if you spotted a technosignature there, a technosignature being any sign of technology rather than mere biology, some glow or structure or pattern that only a mind could make, you would be seeing the past. The civilization that made it might have been gone for an eon. You would be reading a letter from the dead, sent by beings who could never receive your reply, because your reply would take just as long to crawl back, arriving in a future they will never see. Every message across cosmic distance is a message in a bottle, and the tide takes so long that the sender is always gone before it lands. The James Webb Space Telescope has been staring into the deepest, oldest reaches of the universe, catching galaxies as they were when the cosmos was young, their light stretched and reddened by that expansion of space we spoke of, that redshift, where the waves get pulled longer and shift toward red as they cross a growing universe. And it has found something that surprised even the people who built it. Galaxies already assembled and shining far earlier than anyone expected, mature structures at a moment the cosmos was supposed to be barely getting started. And what that telescope shows us, more than anything, is how much of what we look at is ancient. We are always seeing the universe as yesterday, never its today. There is no today out there, only a mosaic of 1 million different pasts arriving all at once, each patch of sky showing a different age of the cosmos depending on how far the light has come. We do not see the universe. We see its memory. And that mosaic is stranger than it first sounds. Look at one galaxy and you see it as a young thing, freshly formed. Turn slightly and see another as it was in its prime. Turn again and catch a third as it neared its end, all in the same glance, all at once, though the light left each of them at wildly different times. Nothing you see in the night sky shares a single moment with anything else you see. It is a picture assembled from 10,000 different eras, pasted together only in your eye. The word now, out there, simply has no meaning we can use. There is only here and now, right where you stand, and everywhere else is some flavor of the past, delivered late. So here is the third revelation, and it may be the one that stays with you. The silence is not only across the room, it is across the ages. We might be alone, not because nobody else exists, but because nobody else exists now at this thin sliver of time we happen to occupy. We could be the first, we could be the last, we could be the lonely middle, born too late to meet the ancients and too early to greet the ones still coming. And every one of those possibilities produces exactly the silence we hear. Not one of them requires that we be special, only that we be somewhere at some time and that the others be elsewhere at some other time. Now watch what happens when you lay all three of these side by side, because they are not three separate answers. They are three walls of the same room, and the room they enclose is very quiet. The first wall was the odds. We have one example of life, and one example is not a probability. The universe is vast beyond speaking, but vastness only guarantees company if the odds fall in a certain range, and we simply cannot know if they do. So the crowd we expected may never have been counted at all. The second wall was distance. Even a galaxy full of neighbors would be a galaxy of the marooned. The arithmetic of light years and escape velocity and the light speed limit does not bend for cleverness. Separation is the default state of space-time. The gaps are the main event. The third wall was time. Even neighbors who exist, even neighbors close enough to reach, would have to burn their brief spark in the same cosmic instant as ours, and the odds of that overlap against a 14 billion year backdrop round down to nothing. And because light is always old, even seeing them is seeing their past. Now here is the convergence, the thing that makes all three click together. Notice that not one of these walls requires anybody to be rare. Read that again slowly. You do not need life to be a miracle. You do not need us to be special. You do not need the universe to be hostile or empty. Each wall, entirely on its own, produces a silent sky, even in a cosmos absolutely teeming with life. And when you stack all three, the silence stops being a mystery and becomes the expected result. Of course it is quiet. How could it possibly be anything else? To get a loud, crowded, chattering sky, you would need all three walls to fall at once. You would need life to be common, and the distances to be crossable, and the timing to overlap. Fail any one of those, and silence follows. And we have no strong reason to believe even one of them falls in our favor, let alone all three together. Think about what those three conditions really demand together. Life would have to start easily, so the galaxy fills up, and the light speed limit would have to somehow not matter, so the distances shrink, and civilizations would have to last for millions of years, so their sparks overlap in time. Every one of those is a long shot on its own. Ask for all three at once, and you are asking the universe to line up three separate miracles in a row just to produce the crowded sky the old stories promised us. Whereas the silent sky asks for nothing unusual at all. It is what you get by default. And when one explanation needs three miracles and the other needs none, you already know which way to lean. This is where that great old puzzle, the Fermi paradox, quietly dissolves. The Fermi paradox is the simple, nagging question: if the universe should be full of life, then where is everybody? For decades, it has felt like a paradox, a genuine contradiction demanding some dramatic resolution. Maybe they are hiding. Maybe they destroy themselves the moment they get clever enough. Maybe we are in a kind of cosmic zoo, deliberately left alone to develop. Each of those is a story invented to explain a silence that felt like it needed explaining. But look at what we have built. There's no contradiction to resolve. The premise was wrong. The universe should not be obviously full of visible, reachable, contemporary company. Three independent walls each guarantee silence. The paradox was never a paradox. It was a mistaken expectation. And once you see the walls, the expectation crumbles and the quiet makes perfect sense. And here is where Occam's razor does its quiet work. Occam's razor is the principle that you should not invent complicated explanations when a simpler one will do. You do not need a galactic conspiracy of hidden aliens to explain the silence. You do not need self-destruction as a cosmic rule that every civilization obeys. You do not need a zoo or a filter or any grand hidden machinery. You just need odds we cannot measure, distances that do not shrink, and time that does not overlap. Every one of those is not an assumption, but a plain fact about the universe we already live in. The simplest explanation for a quiet sky is that a quiet sky is exactly what a living universe would look like from any single vantage point inside it, ours included. There is one more thing the convergence gives you, and it is not about them, it is about you. Apply the Copernican principle, the humility that says, do not assume you are special. Applied here, it does not make you smaller, it makes your situation ordinary. Whoever else is out there, whenever and wherever they are, faces the very same three walls. They look up into the very same silence. They ask the very same question, and they too cannot tell whether the quiet means empty or merely far. Your loneliness, if that is what it is not a private curse. It is the standard condition of any mind that wakes up anywhere in this universe. Everyone is alone in the same way, which is a strange and almost tender thing to realize. If there are 10,000 civilizations scattered across the galaxy's history, then 10,000 times some being has looked up into a silent sky and wondered exactly what you are wondering now. You are not the exception, you are the rule. Repeated across the dark. So the three walls do not compete. They cooperate. Odds, distance, time. Each sufficient on its own. Together, overwhelming. And the sky goes quiet, not because the universe is barren, but because that is simply how a full universe sounds from the inside. So let us bring it home. We started with a number, 2 trillion galaxies, an ocean of stars, worlds beyond counting, and one small planet where somebody is apparently home. And the puzzle was the mismatch. All that room, all that time, all those chances, and a sky that will not answer. We did not reach for aliens or conspiracies to explain it. We built a toolkit instead. We reminded ourselves that light is old, that to look out is to look back, and that there is a wall of oldest light, the cosmic microwave background, beyond which knowledge itself runs out of room. We learned to count planets by the shadows they throw across their stars and the wobbles they pull in their suns, thousands of them, proving that worlds are the rule and not the exception, with many sitting in the Goldilocks zone where water could pool and stay. We even learned to taste their air by the light that filters through it. We insisted that every claim be falsifiable, killable by some possible observation, or else it is just a story. And we borrowed the humility of the Copernican principle, the refusal to flatter ourselves into the center of things. Then we walked into the first wall. The odds, we have exactly one example of life, and one example is an anecdote, not a probability. Worse, our own existence cannot be evidence that life is common, because we could only ever find ourselves on a world where life had already succeeded. The Drake equation showed us how to be honest about that, breaking the great question into a chain of fractions, some of which we now know well, and some of which we cannot pin down to within a factor of a trillion. The vastness of the universe was supposed to guarantee company, but we saw that vastness only helps if the odds sit in a certain range, and we have no way to know if they do. Enormous is not the same as guaranteed. Push the odds small enough, and the entire observable universe holds room for exactly one living world. Perhaps this one. Then the second wall, distance. We built the scale until it hurt. Our fastest machine needs 70,000 years to reach the nearest star, and 2 billion just to cross our own galaxy. And the speed of light is a ceiling nobody escapes, woven into space-time rather than waiting on better engines. Escape velocity and the raw energy of leaving even one planet showed us that the gaps between stars are not obstacles to be engineered away. They are the default condition of space-time. A galaxy full of life would still be a galaxy of the marooned. Everyone shouting across a room, too vast for any shout to cross. Every reply arriving centuries after the sender is gone. Then the third wall, the strangest one, time. We squeezed the whole history of the universe into a single year and found that all of human existence fits into the final seconds before midnight, and our ability to signal into a mere quarter second of that year. And we saw that two civilizations, each a brief spark, would have to burn in the very same cosmic instant to ever meet. The odds of that overlap round down to nothing. We might be the first. We might be the last. We might be the lonely middle. And because light is always old, even to see a distant techno signature would be to read a letter from the long dead. And then the walls came together. Not three answers, but three sides of one quiet room. And the revelation underneath all of them, the thing worth carrying out of here, is this: not one of these walls needs anybody to be rare. A universe absolutely bursting with life would still, from any single vantage point inside it, look exactly this silent. The Fermi paradox was never a paradox. The expectation was simply wrong. And by Occam's razor, we need no conspiracy, no self-destruction, no galactic zoo. We need only odds we cannot measure, distances that will not shrink, and time that will not overlap. The silence is not the failure of a living universe. The silence is the sound a living universe makes. Now, let me be honest about what we still do not know, because that honesty is the whole point. We do not know the odds on a single throw. We may never know unless we find a second independent origin of life, and the best place to look is close to home. A biosignature, some chemical fingerprint of life in the clouds of a nearby world, or under the ice of a moon in our own solar system, where a hidden ocean may sit warm beneath frozen crust, or in the atmosphere of an exoplanet read by starlight passing through it. That same transit trick now used to sniff the very air of another world. Find life just once more, arisen on its own, and everything changes. That single second example would tell us the first fraction is not vanishingly small, and the whole picture would tilt hard toward a crowded cosmos. We do not know how long civilizations last. That fraction, whether they endure for centuries or for millions of years, swings the answer more than any other. And we have no way to measure it from a single case. Ourselves, still living inside our own first few seconds, unable to see how our own story ends. And there are genuine puzzles knocking at the edges, honest reminders that the boundary of our knowledge is close and real, interstellar objects. Wanderers that drift into our solar system from beyond it, past the Kuiper Belt, that ring of icy bodies at the edge of our own sun's family, and in from the true dark between stars. There was the one called Oumuamua, and the more recent one cataloged as 3I, Atlas, and they have shown behavior we are still working to fully explain. Small non-gravitational accelerations, tiny nudges in their paths, not accounted for by gravity alone, as if something gave them the faintest extra push. Almost certainly these are natural comets, venting gas as they warm the escaping vapor, acting like a whisper of a rocket, nothing more. That is what Occam's razor points to, and that is very likely the answer. But they are a healthy reminder. The boundary of what we know is real, and it is closer than we like to admit. And the honest mind keeps looking right at it, refusing both the temptation to cry aliens and the temptation to pretend every question is already closed. And notice the discipline in that. We do not need these visitors to be spaceships for them to be thrilling. A rock from another star system drifting through our own is astonishing enough on its own terms, a genuine piece of somewhere else delivered to our doorstep. We do not have to inflate the wonder. The plain truth is already extraordinary. There is more we cannot see at all. Most of the matter in the universe appears to be dark matter, something that pulls on things with gravity, but gives off no light for us to catch. And we do not truly know what it is. We map its presence by watching how its gravity bends the light of distant galaxies. A trick called gravitational lensing, where mass warps space-time enough to act like a lens, magnifying and smearing the galaxies behind it into arcs and rings. We can weigh what we cannot see, but weighing is not knowing. Even the stuff the cosmos is mostly made of remains a question. So when we ask whether we are alone, we ask it as beings who have only lately learned how much of our own home lies beyond our sight. We are newcomers to our own house, still finding rooms we did not know were there. So here is where the boundary sits. We know the universe is vast. We know worlds are common. We do not know if life is common. We do not know if it lasts. And until we do, the silence tells us nothing except that we are looking from inside. And maybe that is the most wonderful part of all, because you happen to be alive in the exact sliver of time when a species first grew the tools to ask this question with real rigor, to count the galaxies, to weigh the odds honestly, to read the light of the young universe, to sniff the air of worlds we will never touch, to know precisely how far our own ignorance extends, and to be able to name the walls even as we press our hands against them. For every generation before ours, this was a question you could only answer with a myth. We are the first who can answer it with arithmetic, and with an honest shrug where the arithmetic runs out. That is not a small thing. That is arguably the whole point of being here. You are one mind on one world in one thin second of a 14 billion year story, looking up, and you can hold the entire cosmic perspective in your head at once. The vastness, the silence, the odds, the distance, the time, all of it understood, even if not yet answered. The universe is knowable, but not yet known. And that gap, that unfinished space between what is real and what we have figured out, is not a disappointment. It is the most thrilling frontier there has ever been. The answer is still out there, and you get to be alive while we look for it. So look up tonight and know that the silence you hear is not emptiness, it is a question that has not been closed yet. And you are one of the very few in all the ages of this world who gets to hear it clearly and understand exactly why it is quiet and still find it wonderful. If you found something here worth thinking about, I would be grateful if you would subscribe and stay a while. There is no rush and nothing to buy. Just more questions like this one, taken slowly and taken seriously for anyone who still finds the sky astonishing. Thank you, truly, for giving this your time. Time is the one currency the universe never gives back, and you chose to spend some of it here, wondering alongside me. That means more than I can easily say. Look up again soon.